And with introduction to rational expressions, rational just means it's a fraction. So everything they're looking at pretty much in Chapter 7, you're going to be dealing with fractions in some shape, form, or another when we're going through everything. And the very first thing that they have us do when you're going through these is they take you back to just almost a basic fraction when you're going through the different pieces on this one. And pretty much, I mean, you can almost take it back to something like 35 over 75. And if they ask you to simplify that one, what would you do? Find out what you've got in common, divide it by that number, right? In that case, 35 and 75, you can divide them both by 5. You can make it 7 over 15. And some of the problems, you're going to be basically doing that. Now, they're going to add some variables in because that's where the rational part of it really comes in. So what they're going to have you do then is they're going to basically take that exact same number that you have. And we'll do something like this, where you've got 72 x to the 6th. And let's put that over 8x to the 4th. Okay, and when you're doing the rational expressions, do it in two parts. For me, that's the way I've always looked at it. That you're going to simplify the numbers. And the fancy word for numbers is coefficients. And for the variables, you're going to subtract the exponents. Okay, so when you've got something like 72x to the 6th and 8x to the 4th, for me, the first thing I'm thinking is I'm going to go ahead and break this thing up into two parts. And you can just kind of separate that. You've got 72 over 8, and you've got x to the 6th over x to the 4th. And if it helps you to put a multiplication in the middle, you can do that, because if you've got things multiplied together, you can separate them out into pieces and just put the dot in between it to show the multiplication. But again, you're just going to take 72 over 8 and just divide that, simplify it like it's a regular fraction. Now, don't tell me you're going to reduce it, because here's that fraction reduced. There you go. That's reduced, right? It's smaller. That's not simplified, that's reduced. You know, if you want to enlarge it, there you go. Make it bigger, right? Yeah. So, you know, be careful with the words there. Okay, so 72 and 8, you can divide them both by 9. Sorry, divide them both by 8. And that'll get you a 9 over 1. Okay, with the exponents, subtract them, right? So for the x part, you've got 6 minus 4. Well, that's x squared. And if it's been a while since you've done anything with exponents and you're trying to remember, you know, why we're subtracting them, if you go back to 7th grade math, probably, you've got 6 x's and you've got 4 x's. Well, you can go back and cancel everything out, right? Cancel out those, cancel out those, cancel out those, and cancel out those. What have you got left over? You've got 2 x's, right? And they're in the numerator. So here's the biggest thing. Here's where we try to keep things as simple as you can. If you subtract the numbers, wherever the bigger exponent is, that's where your leftovers are going to be. So we've got 9 over 1, and when we have the x squared, that's going to be in the numerator. So that's 9x squared over 1, which you don't really need the 1. Just take the 1 off and make it 9x squared. All right, if they give you more than one variable, just do it one variable at a time as you're going through this thing. So let's go with 45 u to the third v to the fifth. Go with 36 u to the 4th v. Again, in my mind, I'm breaking this up into pieces. I'm doing the 45 over 36, I'm doing the U3 over U4, and then I'm going to do the V5 over V. And again, sometimes it helps just to do the little things, the easy things. If you have a V that's here without a power, how many V's are in the bottom? Got one, right? So for that one, sometimes it's easy to kind of slip by. Put a 1 there. And then take it, break it down a piece at a time. 45 and 36, you can divide them both by 9. 3 will work, but the bigger number would get you 9. So 45 divided by 9, that's a 5. 36 divided by 9, that's a 4. Okay, U3 and U4. Subtract 3 and 4. That's 1, right? But the bigger power is in the bottom, so the leftovers have to be in the bottom. So you need a u to the first or just a u in the bottom. Okay, so we can take that one out because I don't think they'll let you put that in the answer. Alright, V5 and V1. 5 minus 1 is 4. Your bigger power is in the top, so you got to have 4 V's left over in the top. There you go. So no matter how many variables they give to you, just take it one piece at a time. Simplify the fraction first, and then just take one variable at a time as you go through those to take one of them and break it down. Okay, so once they've kind of given you some where it's just basically it's just a fraction with some variables behind it, here's where we actually start digging into more expressions. And the very first thing they're going to ask you to do is they're going to ask you to, oh, not that one. Let's try that one. It's not going to work. Because they're going to ask you to find the restrictions. Now, and they kind of flip-flop back and forth. One time they call it restrictions. In one part of it, the next part of it, they're going to call it excluded values. So one time it says restrictions, one time it says excluded value. It's still the same thing when you're going through this part of it. And for anything that we're going to do, it's just the denominator. The numerator doesn't really bother anything on this one. It's always the denominator that you've got to find the restrictions when you go through this thing. Okay, and one simple little thing to do this one. To do this, just set the denominator equal to 0. And that's it. That's all you have to do. And what that does is, and again, this will kind of take you back to some different parts of it, is that if you had let's go with 5x plus 4 over x minus 9. And they tell you, all right, find the restrictions on this rational expression. All you're going to do again is just take that x minus 9 that's in the denominator and set it equal to 0. And easy enough for the solving equation on this one. You add 9 to both sides, so that's x equals 9. Okay, there you go. There's the restrictions, or the excluded values, or ever how they want to word it for that thing. Now, here's the reason why that works. Here's why you have to get rid of that one value. What happens if we did put, and you don't have to write this down, this is just kind of talking and explaining here. What happens if you plugged in that 9? That's 9 minus 9 on the bottom. You have 5 times 9 plus the 4 on top. That's 45 plus 4, that's a 49. That's 49 over 0. Okay, now, here's where, and this is me going back in time to when I was doing this. Does anybody know without a shadow of a doubt what that answer is? Okay. Do you know that you have the answers in your hand to that question? Let the calculator do it for you. If you punch in 49 divided by 0, this calculator says, that's an error message, right? And if you get an error message, that means that number is undefined. So that's the restriction they say is, all right, you can plug in any number into this thing you want to. But if you plug in 9, you don't get an answer for this thing. It's undefined. It's no solution. It's whatever you want to call it there. So that's why they're setting you up for this restriction thing, is that if you want to plug these numbers in and work something out, any number other than 9, you get an answer. You plug in 9, your calculator says, no, you can't do that. Because it can't all be that easy, right? Yeah, no, we got to make it a little bit tougher. Okay, let's go with y minus 5 over y squared minus 25. And again, as long as they're asking just for restrictions, you really don't care what's in the numerator. All you're worried about is what's in the denominator. So for this part of it, to find the excluded values, you're just going to set y squared minus 25 equal to 0. Okay, now there's something that they call it's the fundamental theorem of algebra. And basically it says this, that whatever your highest power is in the equation that you're solving, you got to have that many solutions. So if you start back up, if we go back from up here, this was x to the first power, we had one solution. If this is y squared minus 25, you're looking for 2 answers. If we had y to the third, you need 3 answers. So whatever part you're doing, whatever the highest power is in the problem, that's how many answers you're looking for. So for this one, we're doing y squared 25, we're looking for 2 answers. So, got to factor this thing. And does anybody remember the shortcut factoring we used on this one last time? Because you've got y squared would be y times y. That's a perfect square, right? So it's y squared and 25, you need a 5 and a 5. Just got to make one positive and make the other one negative. Because if you do positive 5 times negative 5, that's the negative 25. And if you go back and do the full method, you have 5y and a negative 5y. And that'll make a 0y, and that's why there's nothing in the middle there. So if you've got 2 perfect square numbers, just remember you're going to break them up as one's a plus and one's a minus. And once you've got the parentheses, just take each parentheses and set it equal to 0. Subtract 5 from both sides to get negative 5 for this one. Add 5 to both sides to get a positive 5 for that one. And in the homework, when they ask you if you have more than one answer, you're going to separate those answers by a comma. So when you're putting this answer in the homework online, you put a negative 5 and you put a positive 5, which you don't have to put the plus for the positive. So just negative 5 and 5. Okay, so that's where they're going to make you go back and do the factoring on these. That when you find excluded values, if you have x squared in the bottom or y squared or whatever the variable is, more than likely you're going to have to do a little bit of factoring when you go through those. Okay, and from that part, bottom of the page, let's just start the page here. They're going to ask you to now start simplifying. And with the simplifying, they're going to tell you, all right, for now, don't worry about the restrictions. We're going to get to that a little bit later when we do some more things. But for now, we're just going to have you simplify and go through these. And pretty much the direction is just going to say just simplify. What that really means is you're going to have to factor and cancel. Okay, they start you off with a problem that should be pretty straightforward. And they'll actually factor this out for you. You just have to go back and cancel on this thing. So you have something like this. 4 times 2x plus 5. All times x minus 8. Let's put that over 40 times 2x plus 5 times x plus 8. Okay, and it's still kind of like the earlier part. It's still a fraction, it's just a little bit bigger fraction now. But you can still look at it in two parts. That you can work with just the number part. If you have 4 and 40, divide them both by 4, make that 1 over 10. And everything else, you're just going to cross out what you have in common. You've got an x plus, or 2x plus 5 and a 2x plus 5, so that's gone. And as much as you would like to cancel the x minus 8 and the x plus 8, if it's that one little sign different, you cannot cancel those. They have to be identical to cancel those. So for that part of it, those two things would be left over. So you've got 1 times x minus 8, and that's over 10 times x plus 8. And since it's 1 times, you really don't need the 1, so you can just make that x minus 8 over 10 times x plus 8. Okay. And again, right now they're not worried about the restrictions. We'll pick that back up a little bit later. But for now, they're just asking to go back and just kind of work through those and just cancel out the common things that you have there. Okay, for example 2, almost the same thing, just a little bit different. Let's go with 15 over 20, x minus 3 to the third, 2x plus 7 to the fourth, and on the bottom we're going to have a 20, a 2x plus 7 squared, and an x minus 3 to the 7th. Okay, same thing. Now this one, it's a little bit kind of out of order because you've got the x minus 3 here and x minus 3 here. So you can rearrange it if you want to, but in this case, since it's all pretty much there, you can just take it a piece at a time. 15 and 20, divide them both by 5. So that'll make that 3 over 4. Okay, in the parentheses, you've got an x minus 3. Actually, you've got 3 in this one, and you've got 7 here. It's still that same thought process, that if you've got x minus 3 to the third and x minus 3 to the 7th, you're just going to still subtract the exponents. So if you do 7 minus 3, that's 4. The bigger power is in the bottom. So we're going to have an x minus 3 to the fourth power in the bottom. Because we're going to subtract those two numbers. And for the 2x plus 7s, you're going to subtract those two numbers. 4 minus 2 is 2. The bigger power is in the top, so your 2x plus 7s will be left in the top. Okay, so whenever, and again, if it's a little bit out of order, just realize that you've got to work with the 2x plus 7s, subtract those exponents. The x minus 3s, you've got to subtract those exponents. And again, the only difference is instead of it just being x's and y's, now it's x plus 3s and x minus 7s, and just different expressions if you want to put them in there. Now, somebody's probably asking or thinking, do we have to write out x minus 3 times x minus 3? No. Just leave it as x minus 3 to the fourth. They don't want you to write it out, 3 or 4 or 5 different times when you're going through those. Okay, example 3, you're still simplifying. The hint they give you with this one is they're going to tell you to use the GCF. So now again, the directions are still simplify, but a lot of times if you look in the directions, they'll kind of give you a hint as to what you're looking for. This one, they're going to tell you you're simplifying, hint, hint, look for the greatest common factor if you're going through this thing. So we'll go 2v squared minus 12v. That's over 5v squared minus 30v. Now, here's your public service announcement for the day. Don't be that guy or don't be that girl who says, oh, look, I've got 2 and 30. I'll just go back and cancel this 2 and that 30 and that 12 and, and just start canceling stuff. Anytime you've got variables with pluses and minuses, you've got to think about that as having a parentheses around it. And before you can cancel, you got to have identical things in the parentheses. And right now, you don't have anything close to that. So that's why they're telling you you've got to do the greatest common factor on this one. So anytime you get variables and there's pluses and minuses, put parentheses around it. And we didn't have to do that back up here on, well, it's on the other page, where it was all multiplied together because there were no pluses and minuses. Everything was crammed together. So that part we could just start canceling going for it. This one you are going to have to take out the greatest common factor. All right, on the top, you've got 2v squared and 12v. 2 and 12, you can divide them both by 2. They both have a v, so let's take one of them out. 2 divided by 2, that's going to be a 1. But we're going to have a 1v, so we don't have to really put the 1, so we just put a v there. Negative 12 divided by 2, that's a 6. We took the v out, so it's just going to be v minus 6 on the inside. And the bottom part, 5 and 30, you can divide them both by 5. They both have a v, so we'll take that out. When you do that, you're left with 1 and a v on the inside. 30 divided by 5 is 6. All right, now that you've factored everything out, now you start, hopefully the light bulb is going off. Now you've got a v minus 6 in parentheses and another v minus 6. So now you can cancel those two out. And you've got 2v over 5v left over. Well, there's nothing you can do 2/5. That's just simplified as far as you can. But since you've got v's on top and v's on bottom, you can cancel those out. So final answer would be just 2/5. And again, the problems in the homework, they're usually pretty good. Go ahead and kind of look at it and see what you think. A lot of times, though, they're going to give you a hint of, okay, we want you to simplify this one and look for the greatest common factor as you're going through this thing. All right, now here's a little I guess, a little hint, a little trick on this one. I wouldn't even call this an example. More like a hint. Hint, reminder, whatever you want to call it. Let's just say for a minute if you're factoring one like this. Let's say you have x minus 6 over 6 minus x. Where you look at it and you go, all right, this is pretty close. I've got the right numbers, but the signs are all out of whack, right? Because we need a positive x, this one we got a negative x. We need a negative 6, this one's positive 6. If you do this where you have the right numbers with the wrong signs, we'll say correct terms, so that we've got both x's, they both have 6's, but the signs are wrong. All you need to do is factor a negative 1 out of one of the expressions. Out of one of the expressions. Okay, so for this one, let's take, because we're used to seeing the x first, and then on the bottom part here, we've got the 6 first. So for this one, let's take a negative 1 out of the bottom part. So top part, we're going to leave it the same. It's fine. It's x minus 6. If you factor negative 1 out, then you would make this a negative 6, and you would make that a positive x. Basically, you know, if you take 6 and divide it by -1, that's negative 6. If you take the negative x divided by -1, that makes it a positive x. And once you do that, we'll now just flip-flop the order, right? So leave that x minus 6 like it is, and then just reverse the order. On the bottom part, let's put the x first, and let's put the minus 6 second. And now you've got an x minus 6 on top, you've got an x minus 6 on the bottom, so then you could go back and cancel those two things out. And when you cancel those items out, remember, you would put a 1 in its place there. So technically, you've got 1 over -1, but that would just be -1. Now, again, a lot of times that's going to be mixed in with some other problems as you're going through those, but it's just one of those things that sometimes if you get, it's kind of like what we're doing in factor by grouping. If you'd done factor by grouping and you had the right numbers but the signs were wrong, then that meant you should have taken out a -5 instead of taking out a +5. So it's that same kind of thing that if you get the right numbers but the signs are off, you just didn't take out the right sign. And that's really where you can kind of tie that back in with factor by grouping. What was that last one? Okay, on example 4. Okay, here's where you finally get to start using your factoring skills. We've kind of a little bit used them here and there. This is the time where you actually get to go ahead and just use everything. This is when they're going to ask you, again, to simplify, and they're going to tell you that to do this, you want to do factoring with a quadratic. So we're going to do your normal factoring. So now the bottom part, nothing you can do there. You've got the x plus 2. The top part, though, you've got to break it down. So on the top part, you're looking for the factors of 20. And it is a positive 20. And you're looking for the pair that's going to have a sum that's going to be positive 12. And the good thing is here, they're all positive, so we're adding things together. 1 plus 20 would be 21. 2 plus 10 would be 12, so there's the pair you're looking for. So for that one, we're going to factor out an x plus 2 and an x plus 10. On the bottom, you've got the x plus 2. And now that you've got exactly the same things there, you can cancel out the x plus 2's. And the final answer would be x plus 10. Okay. Next one, we're going to kick up the factoring a little bit more. Now you've got two parts you've got to factor. You've got to factor the numerator and you've got to factor the denominator to get the number that you're looking for. And again, we'll take it one piece at a time. On the top, we're going to look for the factors of negative 16. And look for the pair that's going to add up to be negative 6. And again, there's not as many choices as you think. It's either 1 and 16, it's 2 and 8, or it's 4 and 4. So with these, sum's negative 6. So if the B term is negative 6, the bigger number has to be negative. other number is going to have to be positive. You negative divide by negative, it makes this a positive. So the pair that's going to get you to negative 6 is going to be a y plus 2 and a y minus 8. Okay, and on the bottom part, first thought, it looks like you're going to have to do the AC method, where you're going to have to multiply 3 times 96. But hopefully you'll notice this one. You've got 3 and 36, dividing both by 3, right? If you take 96 and divide it by 3, it'll go evenly. That'll be 32. So you can actually factor out a 3 before you do anything. So that'll be y squared minus 12y plus 32. And now you've got a smaller number to break down, so for this part of it, you're looking for the factors of 32. And you're looking for the pair that's going to add up to be negative 12. Again, not 1 and 32. Most of the time it's not going to be 1 in the number. They'll sneak it in occasionally, but most of the time it's not. 2 and 16, 4 and 8, or that's it, right? Seems like there should be more, but for 32, that's pretty much about it. All right, the b term is negative. So that means the bigger number has to be negative. And if you do a positive divide by negative, the other number is also going to have to be a negative. So the pair that will get you to negative 12, that's the 4 and 8. All right, so if we put it all together, we've got y plus 2, y minus 8 on the top. On the bottom, we took out the 3, and now we're going to have a y minus 4 and y minus 8. And now that you've got it factored out as much as you possibly can, cancel out what you have there. So get rid of the y minus 8s. So final answer would be y plus 2 over 3 times y minus 4. Yeah, so they're going to keep making you come back and just factor more things and factor more things and factor more things, and just going to keep working through those until you're really, really, really good at the factoring part. Okay, and the last thing before we take a break. Give you one more and then we'll get you out of here. We're just remembering, let me add one more page here, right at the bottom. So we'll go 2y squared plus 6y plus 4 on top. And on the bottom, we'll go y squared plus 6y plus 5. Okay, and again, on the top part, if you're thinking that you're going to have to do the AC method because the first term is 2, again, look at the numbers. It's 2, 6, and 4, so divide them all by 2. So it's going to leave you with a y squared, a 3y, and a 2. And with them all being positive, the good thing about the last number being 2, what's the only way you can get 2? 2 times 1, right? There's no other options you get. So for the top part there, when you factor it, it's going to have to be a plus 1 and a plus 2. Because that's the only way you can multiply whole numbers to get 2 is to do 1 times 2. On the bottom part, kind of the same setup. If you're finding the factors of a positive 5, there's only one pair, right? It's 1 times 5. So same thing on the bottom, there's only one answer you can get there. It's got to be y plus 1 and y plus 5. Alright, and start canceling. That's gone. That's gone. And you're left with 2 times of y plus 2. That's over a y plus 5. Now, if you accidentally went back and multiplied the top part by 2, you'd still be okay, but that answer, do it in factored form as much as you possibly can. So as much as you can factor out of it, just leave it that way.